Welcome to We Do the Heavy Lifting. I'm your host, Dr. Jenny Yentis, and today we do antioxidants. They're everywhere. They're even in my face cream. They're in my blueberries. They're all over the world. What are these things, and do they actually help us? So our expert today is Dr. Adam Case. He is an associate professor at Texas A&M University, and he got a PhD in something called redox biology, and he's published numerous papers and done a lot of studies about oxidants and antioxidants. So, Dr. Case, what is redox biology?
I get that question a lot. Well, thanks for having me today on the podcast. Yeah, so redox biology is just an amalgamation of the words reduction and oxidation. You probably learned about those back in your chemistry class in high school and whatnot. All that is really just a fancy way of talking about how one electron, one of those little subatomic molecules, goes from one molecule to another. That's it. Those processes of an electron going from one molecule to another is oxidation and reduction. Now that's at the very, base level of what redox is. Usually it's affiliated with this concept of oxidants and antioxidants, because really that's how these molecules work, is by giving and taking electrons in the body.
So they give and take an electron. So which one, how does that then come up to be an antioxidant or an oxidant? How does that come into it?
Sure. So it's kind of funny because oxidants and antioxidants are just different words for these reduction and oxidation. So as you can imagine, an oxidant oxidizes, right? Okay. And that basically means it steals an electron from another species. Okay. Antioxidant also reduces. And it's kind of a weird term because what you're actually doing is you're giving an electron when you're an antioxidant. That's a good thing. That's a very good thing to give an electron up. So you might say, why is it called reducing? Well, again, back to your basic chemistry, electrons are negatively charged. So we're reducing the charge that when we give it up. So that's pretty much the idea there of what an oxidant and antioxidant is.
Okay, so as I mentioned in our opening, there are so many antioxidants. I mean, we were overwhelmed with it marketing-wise. I mentioned my face cream has antioxidants. What actually is the role of these antioxidants, or are they even good for us?
Okay, so 30,000 foot view, antioxidants are essential. They are essential to life. If you don't have antioxidants around, ultimately what happens is all the oxygen around you would essentially oxidize you. So think about a piece of metal that gets rusty. What is that happening? That's actually the iron oxidizing. Well, in the same way, you can oxidize like a piece of rust, but you have internal antioxidants that prevent that from happening. And your body makes these, we consume these in our diet. We do this so we essentially don't biologically rust, which would be the equivalent of falling apart, right? So yes, so antioxidants are very, very important, but here's going to be the kicker. Okay. The kicker is the marketing of antioxidants can take it maybe one step too far. Yeah, right, exactly. Because ultimately what happens is our bodies are really good at regulating our level of antioxidants and oxidants. And in very rare circumstances are those really that imbalanced to the point where we need to drink some kind of berry juice or some kind of marketed supplement to actually get us back to that level. And so most often, the good news is that these supplements that you have or the creams that you have, they're not going to hurt you, not by any means whatsoever. But are they going to be the magic cure-all that is going to save your disease or save your skin from wrinkles? I wouldn't always bet on it.
Okay, so then how, if you're taking in so you can't take too many of them, correct? Is that what I'm understanding?
To an extent, obviously, everything in moderation. I think that's one of the keys there. But usually, what happens is when you take in excess antioxidants, your body usually just figures out a way to flush them out of your system. A classic example is vitamin C, right? And vitamin C is been used in many different studies to be a critical antioxidant that people use that they say can be helpful for your immune system and helpful for many other things. So what they'll do is they give people these big pills of vitamin C, but what we've learned is most of it is just excreted. Your body already has a level of vitamin C that it wants to hold, and anything above that just gets flushed out. So it's really essentially not really adding anything to what you already have.
You had also mentioned that usually the oxidant antioxidants are fairly balanced. Are there conditions or injuries that happen that put those out of balance? And do they go one way or the other?
Yeah, absolutely. So virtually, and I don't want to be too broad, but virtually every disease that we know of has some sort of imbalance of oxidants and antioxidants. But I want to make sure that everyone listening knows that it's not that simple. It's not just as simple of, oh, I have more oxidants, so I have this disease, I better take more antioxidants. That's it. That's a kind of very reductive view of it. It's much, much, much more nuanced and specific. So usually what happens is specific oxidants might be elevated or specific antioxidants might be deficient. So this is part of my research and part of a lot of people's research is to really start to refine that so we can stop really using big, broad umbrella terms like oxidative stress and really get to more nuanced terms of which oxidant is potentially leading to which disease so that we can actually target that a lot more precisely.
Okay. Thank you for that, because I did want to ask you what oxidative stress was. You kind of alluded to it, but for our listeners, is there really, what should they think when they hear something or someone talks about oxidative stress? How should they interpret that?
Sure. So I think oxidative stress in the general world is a fine term to summarize the idea of oxidants and antioxidants, right? But in the actual medical field, oxidative stress is something actually very specific. So one thing that a lot of people don't realize is, we've been sitting here talking about oxidants and antioxidants and good and bad, but in reality, oxidants are actually good too. We actually even need certain oxidants to survive. Your body even has proteins specifically designed to make oxidants. So it's kind of this goes back to that it's not as black and white as you can imagine, right? It's very nuanced and specific. And so ultimately what happens is we need these oxidants for normal biological processes. But if at any point they get so far out of control, that's when it can lead to damage, problems, and that's when we term it oxidative stress.
I see. Okay, so oxidants are a good thing for us. Antioxidants are a good thing for us. We can overtake the antioxidant. We can overingest antioxidants. And that won't put us out of whack. We'll just get rid of the antioxidants we don't need.
It is really the old adage of everything in moderation, and really ultimately, when you see all papers and science in this field, you see that everything with oxidants and antioxidants, the happy medium is in the middle. Either end of the spectrum can throw you into imbalance.
Well, it makes sense, right? That's why the adage is everything in moderation.
Absolutely.
So what are ways that we can maybe change, instead of just ingesting antioxidants and oxidants? I've heard things like maybe exercise can alleviate oxidative stress, or there's some people that say it causes some oxidative stress. So the literature is a big mushy pile there about all of that. So anything with exercise is.
Yes.
So could you kind of help our listeners understand what exercise does in that way?
Absolutely. So you hit the nail on the head. exercise is a huge black box, right? but I think one of the reasons it is right now is because the tools up until even now, we're still refining them, but the tools to measure oxidants and antioxidants are sometimes blunt. And so when you're really trying to study a very nuanced field using a blunt tool, sometimes the answers might not be clear. But here's the big take home I'd say with exercise. I don't think there's any physician or any researcher in the world that will tell you that exercise is bad for you, right?
Okay, yeah.
But one of the really counterintuitive things that many researchers have observed, and I'd say it's pretty well accepted now, is that when you exercise, you increase your level of oxidants. Okay. And so a lot of people think, well, that's weird because it's so beneficial for you. Why would it increase what we consider, quote unquote, bad? You'd think it would increase the antioxidants and be good for us. But what we're actually thinking now is that with oxidation or oxidative stress and exercise, what you're actually doing is almost think of it like almost a small vaccination. You are increasing those level of oxidants, but for the purpose that your body can then compensate and adapt. And with every time you exercise, you increase oxidants, you increase the adaptive antioxidants, and it goes up and up and up. So what you're ultimately doing is you're resetting your threshold to be in a much more beneficial state than you were before the exercise. And what's really interesting, and a lot of studies have actually shown, is if you take someone that's been exercising and you give them a bunch of antioxidants to say, hey, let's make sure they don't get those oxidants, they never reset to a higher level.
Really?
Really. So they basically, exercise doesn't have the same benefit it does if you just let those oxidants do their thing in conditioning the muscle and conditioning the body. Like I said, I think of it almost like a vaccine where we give a small challenge to let the immune system adapt. Okay. It's the same idea. You're challenging your body with this low level of oxidants so that it can then adapt accordingly.
So a question that's going to come up is, more than likely, can you over-exercise and have too much increase in oxidants? And then how long is recovery then to allow that adaptation? Is that why we do the 24-hour kind of rest between? Is that where that's coming from?
Right. So to get to the first question, 100% too much exercise is bad. Remember, everything in moderation. And we know this because we know there are conditions like rhabdomyolysis, which is basically breakdown of the muscle with too much excessive exercise. Now, is that a cause because of too many oxidants? It probably contributes to it, okay, right? So we know that there are downsides to excessive exercise, but exercise in moderation absolutely is great. Now you're bringing up the question of recovery and then the question of type of exercise or intensity of exercise, and all these factors come into play. And I will not lie, I am not an exercise physiologist, right?
Fair
so
enough.
I don't want to step on the toes of the people that actually study that. However, I do know that there is this absolutely important critical period after the exercise where we need to let the oxidants in biology do their thing. Otherwise, if we try to intervene too early with antioxidants, we can completely reverse that whole beneficial effect.
Interesting. I mean, really interesting stuff. So I guess my question then comes to those that are on pretty strict schedules, your marathon runners, those that are doing a lot. Is there a point in which you reach a peak oxidant, antioxidant, and then you don't get that benefit of exercise, I guess is kind of what I'm asking?
No, it's a great question. I honestly don't know if that really has been fully examined. My hypothesis would be yes, is that ultimately there's only so much your body can do to adapt, right? And, when you think about how, antioxidants are made in your body, if you just kept making more and more and more, eventually it would, in reality, fill up your cells and there would be no room for anything else. And I guess ultimately what has to be is eventually what you're doing is you're getting to a level where the production of oxidants and the level of antioxidants equilibrate. So I think what ultimately happens is when you're someone who hasn't exercised for a while or never exercised, your level of antioxidants are very, very low, right?
Okay.
Your threshold and your adaptability is very low. So you exercise and the oxidants go up high, you need a while to adapt up there. But in elite athletes, they've kind of already adapted so that every time they exercise, they're always in balance. It's a condition kind of a pathway that levels off over time.
All right. So you've kind of explained how exercise can have this effect on oxidants and antioxidants. But what we really don't know still is, you said there's specific kinds. You mentioned vitamin C, but how do we know what they are and what their roles are?
Oh, absolutely. And this is not only confusion in the general public. This is confusion even amongst many scientists, because the term antioxidant gets thrown around as it's this universal thing that anyone can just take an antioxidant and be good. But what we've learned is that there are so many different flavors of oxidants. And this gets down into the rabbit hole of chemistry and whatnot, but there are just so many different flavors of oxidants that your body makes or your body is even exposed to. Just in cigarette smoke alone, there are hundreds of different types of oxidants.
Really?
Absolutely.
Interesting.
And so the problem, though, is how can we honestly think that if there's hundreds of different types of oxidants, that taking one random antioxidant like vitamin C is just going to be a cure-all, right? This is why you see supplements along the wall at your grocery store that are really trying to market that. But ultimately what we learn, and in the field of redox biology, which I study, is we are trying to learn how do these antioxidants actually target specific oxidants. And so, for example, a lot of people probably have heard of or know of vitamin C and vitamin E. And many times, multivitamins and pills will supplement them with both of those quote unquote antioxidants. But no one I have yet to meet to date, unless they're a redox biology, can actually tell me what does vitamin C do differently than vitamin E. And so I'm going to tell your listeners today, and this might blow some people's minds because I teach this in my class, and I know a lot of my students also look at me with these glazed eyes of, I had no idea. So your cells, every cell in your body, has this membrane that's pretty much made up of fats, right? We learned that it's called a little lipid layer. Lipid's a fancy name for fat. Well, those fats that make up your membranes, they can be attacked by oxidants. Well, your body has ways of fixing those when they get attacked by oxidants. One of those ways is vitamin E. Vitamin E specifically helps reverse oxidant damage of fats. Now, here's where it gets interesting. Here's where it gets really interesting. How it does that is vitamin E gives up one of its little electrons to the fat to rescue it. But now vitamin E is oxidized and in a bad situation, right? And so now it's in trouble. So guess what happens?
Does vitamin C give it?
That's exactly right.
No way.
Vitamin C gives its electron to vitamin E to rescue the vitamin E. And now vitamin C's in trouble, and your cell has a different pathway of giving an electron back to vitamin C. And so it's this pathway, this cyclic pathway that essentially helps you rescue the damaged components of your cell. And that is just one of hundreds of different types of redox pathways that we know about in the cell. So now I hope you and your listeners can really appreciate that that is just one pathway where we talk about vitamin C and vitamin E and how it fixes that one aspect of cells. So now imagine that you have a disease, a complex disease like Alzheimer's disease or cancer or diabetes, where you have thousands of different pathways being affected. Now I hope you can appreciate that taking a simple pill that has vitamin E or vitamin C is probably not going to cut it. And frankly, this is why a lot of the clinical trials in the early 90s giving supplements like vitamin C, vitamin E failed in almost every disease because they really weren't hitting the nail on the head, right? They're really not getting to the cause and effect of why we have disease. And that's where there's people like me that are trying to study that.
That is really interesting. Thank you for sharing that. We always give our guests the opportunity to give our listeners a take-home message. So is there something you'd like to leave them with?
So I guess the take-home message would be this. First and foremost, before you take any type of antioxidant supplementation, talk to your doctor. Because even though they are mostly harmless, some of them can actually interact with medications that you might be taking. And we want to make sure that the medications you're taking that we absolutely do know help with your disease aren't affected by these potential antioxidants. The second thing I'd want to leave you listeners with is healthy diet is everything. It really is, because oftentimes just with a healthy diet of vegetables, fruits, meats, or whatever your diet consists of, as long as it's a healthy, well-rounded diet, you are going to get all the vitamins, all the antioxidants you need, that your body needs to maintain that quality level. Any kind of extra supplement is probably just gonna leave your body as fast as you ate it. So
really expensive urine.
It's really expensive, absolutely.
Well, thank you so much, Dr. Case. We really appreciate you coming on We Do the Heavy Lifting. And to our listeners out there, please feel free to email us at huffines@tamu.edu if you have topics that you'd like us to cover in the future or any comments. We're happy to hear them. Thanks so much and stay safe. Thanks for being here.
Thanks for having me.